Welcome to Understanding Networking Part 2. In this course, we're going to go through two main topics, the Internet and IP security. We'll start at the beginning with the Internet and understand some of the original design decisions and the idea of a connectionless, unreliable packet network and why it might have been designed that way, and what we have to do to make it reliable. Then run through some of the things that have happened recently, like internet service providers, domain names, and MIME. For IP security, we're going to do a general overview and look at the risks and measures. And then we're going to talk about firewalls. And we'll look at the different techniques that are used to implement firewalls, including packet filtering, proxying, and stateful packet inspection. Then we'll move on to look at protecting information and talk about encryption and IPsec and VPNs. The main incarnation of IPsec is a virtual private network. Private network means that you have dedicated point-to-point lines between your locations and nobody else is using these lines. Virtual private network means that that's not true. It just looks like you have point-to-point lines going between your locations. But in fact, if you looked on the actual circuits, there are packets interspersed from many users all running over those lines. The way that we make it look virtually like you have a private network is to use IPsec, key exchange, and encryption to create a whole system of smoke and mirrors. One way that this could be implemented is with customer premise equipment. So the idea is that some organization is going to implement communications across the internet, but do it in a secure fashion. We like to use hardware to do this function for performance and people meddling with the configuration reasons, but of course it can be implemented in software as well. But let's just think it's on a standalone box to explain it. The idea would be that at one location we would put a piece of hardware that's implementing all of this stuff as a choke point between the trusted system and the internet, and then the same thing at the other end. And these are referred to as VPN hardware, VPN boxes. What they'll do is they'll find each other over the internet and authenticate each other and generate a key and then exchange that. Then if somebody in the system that's being protected on this side wants to send a packet to somebody in the system that's being protected on the other side, they will transmit it, but it will be intercepted by the VPN hardware that then will take the packet, use the key to scramble it, and put it inside another packet that's addressed to its friend across the internet. And it'll send it over there. Its friend will receive the packet, look at the ESP header on the front and see that it's encrypted. So it'll take the payload out of the packet, apply the key to decrypt it, revealing the original packet and relaying that onto the safe side at the far end. This is called tunneling in internet lingo, is taking one packet and hiding it inside another. A VPN means using IPsec techniques to encrypt the packet that's hidden inside another one and transmit it. This has advantages in that somebody cannot sniff your data as it's going across the internet, and also people who want to attack the system at the far end, they don't have the key so that they can take packets and scramble them and send them to the far end VPN hardware so that when it uses the key to unscramble them, that they actually mean anything. So it provides some level of network security protection as well. We like to use hardware to implement these things because it would have a dedicated processor, so for performance reasons, and also we can make that a black box that the users in the accounting department are not allowed to touch. Only the IT and network security people are allowed to touch that box. However, we often use software implementations of this as well. Where would that be useful? Well, for people who are traveling, this is how they could use the internet to access servers and clients at work, is establish VPN from their laptop to the firewall at work and establish an authenticated, encrypted, secure connection across the internet, then to get onto the systems at work. And this has replaced the idea of telecommuting using ISDN basic rate and dial-in modems and all that sort of stuff. We use the internet and VPN technology to do that. Implementing a VPN yourself certainly can be done. However, there are companies out there that will do it for you and provide it as a network service. Every telephone company offers VPN service as a commercial service offering. The ideas are just about exactly the same as before. The main difference is that instead of you having to go select VPN hardware, decide what encryption techniques you're going to use, what key generation methods you're going to use, how you manage the keys and all that stuff, is that some people at the phone company will go figure all that out, buy the equipment, and provide it as a service. So what we end up with is an IP packet network service that has guaranteed confidentiality in the middle. That's what the VPN gets you. Whether it has QoS, guaranteed transmission characteristics, is a separate story. This gets us secure communications across an IP network. And it certainly is one of the service level agreements that you can sign with a telecommunications service provider for doing communications using IP. It might be going over the internet. It might just be going over their IP network, but your data is encrypted and protected. All of the services like dedicated T1s and frame relay and ISDN and native ATM will all disappear and get replaced with this IP VPN services. Now the VPN, this is the IPsec protocols, encryption and so forth, this gets us secure communications across an IP network. Carriers will then add more services in at the network layer to guarantee quality of service. They'll be using MPLS to do actual switching of packets and to be able to implement quality of service by differentiating between packets that contain voice and packets that contain data and sending them over different MPLS virtual circuits, all of it encrypted using IPsec. And once this is all in place, we'll just have one network service called IP, and there will be different service level agreements you can sign. And believe it or not, this is one of the main reasons why carriers want to go to voice over IP, is to reduce their operating costs so that they just have one network service. They don't have frame relay and T1s and POTS and ISDN. They're just an IP network.